Good day, everyone. Thank you for joining us here for the 18th Canadian Underground Infrastructure Innovation Center Academy webinar. And today we'll be talking about trench safety awareness. I'm Jason Lueke, the National Discipline Leader for Trenchless at Associated Engineering and Chair of the CUIIC Education and Outreach Committee. I'll be your moderator today. All these webinars are organized by the Canadian Underground Infrastructure Innovation Center, the University of Alberta, and Benjamin Media. CUIIC Academy offers classes, courses, webinars, and events to help further underground infrastructure education opportunities across Canada. The webinars occur on the third Thursday of the month. Please join us for the next one here on July 18th. It'll be on an artificial intelligence approach to data collection for utility surveys, engineering designs, and digital twins presented by Douglas Culbert, Chief Data Officer for Spatial Data Analytics. For a full list of upcoming webinars and past webinars, please visit our website here at academy.cuiic.ca. Big thank you goes out to our 2024 webinar series sponsor, Westlake Pipe and Fittings. Thank you very much for helping make these webinars possible and keep them free for everybody. So I'm going to get right down to the webinar here. I'm going to introduce our presenter today, Jarrett Patrie. He's the Regional Manager of Cooper Trench Safety. He's managing operations Western Canada for Cooper Trench Safety. He's got 14 years of experience in the trench safety industry, providing site-specific shoring plans and introducing new innovative products into the market. So welcome, Jarrett. As we're going along, if there's any questions, please put them into the question panel on the bottom, and at the end of the presentation, we'll have an opportunity to interact with Jarrett and ask him some questions. So again, welcome, Jarrett, and the floor is yours.
Right on. Thanks a lot, Jason. Good morning, everyone. I'd like to start off by thanking CUIIC for allowing me to speak with the group this morning during Trench Safety Week. Today we'll be discussing the following areas of awareness: why trench shoring is required, excavation incidents, OH&S code and OH&S regulation, soil classifications, and trench shoring products. So why is trench shoring required? Number one, OH&S regulation. Any excavation 5 feet or deeper required the walls of an excavation to be sloped at an appropriate angle depending on the soil classification. That's typically a 1-to-1 or supported by a trench or a temporary support structure, in essence a trench box. Number two, existing utilities and structures. With existing buried utilities, sloping the excavation walls is not always possible without risk of damaging existing infrastructure. And three, reduce the cost reduction and efficiencies. Reduce the remediation and transport costs with a straight cut trench compared to an open cut. This may allow you to save costs on fuel, labor, equipment wear and tear, and asphalt. Trench collapses are considered to be the most dangerous types of construction accidents. When the proper protection measures are not used to prevent a trench collapse, workers can sustain serious and life-altering injuries or even death. I'd like to note a few incidents across the country, with some close to home where workers have been severely and fatally injured. As employers, we need to ensure that workers are aware of their rights, and working in an unprotected trench must be refused. So we'll kind of get into it here. August 8th, 2022, two workers died and 2 others were injured following a trench collapse at a construction site in Ontario. October 30th, 2018, an incident left 1 worker fatally injured in Edmonton. The worker was inside a trench greater than 3 meters by 6 meters wide, working to level it. However, the south bank gave way, covering the worker to their neck. In June 9th, 2023, around 10:45 a.m., First responders were called to an alley in Calgary after a large amount of earth and retaining wall of cinder blocks buried a man who was on a ladder doing a sewer line repair in a 3 to 6 meter deep trench. July 13th, 2023, 2 workers were injured in a trench collapse at a residential construction site on Vancouver's west side. And in April 28th, 2015, a 55-year-old worker in Edmonton is dead after he was buried under more than a meter of clay and in dirt in the backyard at an infill project. So obviously, people taking unnecessary risks resulted in injuries and fatalities. So getting into the OH&S code regulation, 450-1, methods of protection. Before a worker begins working in an excavation that is more than 1.5 meters deep, must ensure the worker is protected from cave-ins or sliding or rolling materials by either A, cutting back the walls of the excavation to reduce the height of the remaining vertical wall, if any, to no more than 1.5 meters. This can only be achieved in hard and compact soil or likely to crack and crumble. Option B would be installing a temporary protective structure, or C, using a combination of the methods in both clauses A and B. So when using a combination of protective structures and sloping, ensure the trench box extends at a minimum 18 inches above the toe of the slope, and the soil pile at least 1 meter away from the edge of the excavation. This is to prevent any roll-off material from entering the excavation. Just please note, excavation regulations vary from province to province. So refer to your government regulations where your project is situated. We'll get into classifications of soil. OH&S Code Regulation 442, hard and compact. So the description on that is hard in consistency and can be penetrated only with difficult by small sharp object, is very dense, appears to be dry, no signs of water seepage, and has not been excavated before. Classification 442-2, likely to crack or crumble. Description: has been excavated before, but does not exhibit the characteristics of soft, sandy, or loose soil. Stiff in consistency and compacted. Has low to medium natural moisture content and a damp appearance after it has been excavated, and exhibits signs of cracking and localized water seepage. (442-3), soft, sandy, or loose, is firm to very soft in consistency, loose or very loose, solid in appearance, but flows when it becomes unstable when disturbed, runs easily into a well-defined conical pile when dry, appears to be wet, granular below the water table unless water has been removed, exerts substantial hydraulic pressure when a support system is used. So when we take a look at these descriptions and relate them to the tabulated data that we provide as a supplier, we start to see some discrepancies when it comes to the definitions. In the US, they have a standard soil classification across the country. Then the manufacturers work to create their tab data. In Canada, the soil descriptions and classifications can vary from province to province. So the common type that we as a supplier defer to is a C-type soil. That's not knowing any parameters of your job. We will automatically look at a C60 type soil on our tabulated data. It's important to note that inspections of excavations, adjacent areas, and protective systems shall be completed by a competent person on a daily basis to look for evidence of a situation that could result in a cave-in. Inspection should also be performed after a rainstorm or other hazard increasing occurrence. Temporary protective structures, 456. An employer must ensure that a temporary protective structure in an excavation, 3 meters or deep or less, are of sufficient strength to prevent the walls of an excavation from caving in or otherwise moving into the excavation. Or B, more than 3 meters deep are designed, constructed, and installed in accordance with the specifications of a professional engineer. I spoke with OH&S on this topic here on 456.1a on how they come to the determination of sufficient strength. And they kind of came back to me with that they would refer to the Schedule 9 shoring dimensions chart in the Alberta Occupational Health and Safety to determine if that shoring system is of sufficient strength. For documentation on an engineered system, always have the tabulated data for the trench box or shoring system on hand, as it provides a number of details on the specifications of the system. You'll have a serial number, each tabulated data sheet specific to the serial number, so ensure that they match. You'll have a model number, which describes the dimensions of the trench box, typically height times length. You'll have a maximum depth chart, trench box depth rating by soil type. This chart is based off of OSHA soil descriptions, so a comparison between OSHA description and the local regulations will need to be completed. And then you'll also have some manufacturer's notes and conditions around the proper use of the trench box to ensure that it's used properly in the excavation there. If site conditions warrant the tab data invalid, a site-specific engineered plan can be implemented to ensure the shoring system is compatible to meet all conditions. These site conditions may include water table or soil conditions, traffic and railway surcharge loads, or building foundation loading. When we talk about temporary protective structures, we consider two different methods, shielding and shoring. So shielding means a structure that is able to withstand the forces imposed on it by a cave-in and thereby protect the workers within the structure. Basic installation is to excavate the trench and then install the trench shield. A couple key notes is to, in a dragging application, the max distance between the outside of the trench shield wall and the edge of the excavation should be no more than 6 inches. In the event of a cave-in, you want to ensure you limit the lateral movement so it doesn't pose a risk for the workers inside the trench. Secondly, if the trench box is to remain stationary, it's recommended that the trench shield be backfilled 2/3 to prevent any lateral movement. Shoring means a structure that is such as a metal, hydraulic, mechanical, or timber shoring that supports the sides of an excavation and which is designed to prevent cave-ins. Under 458.1, an employer must ensure that a worker who installs shoring, stringers, or bracing uses a ladder and works down from the top of the trench, installing each brace in a descending order. 458.2 must ensure that a worker who installs shoring, stringers, or bracing uses a ladder and works upward from the bottom of the trench, removing each brace in an ascending order. Slide rail systems and sheeting and bracing installations follow the same method. We excavate inside the systems by pushing posts and panels down or adding rings of bracing as we descend to the final depth. In addition to not allowing the excavation to cave in, we also limit the soil disruption outside the excavation. For removal of these systems, we reverse the installation method by backfilling and ascending the shoring system. OH&S Code Regulation 455-1, safe entry and exit. An employer must ensure that if a worker is required to enter a trench that is more than 2.5 meters deep, a safe point of entering and leaving is located no more than 8 meters from the worker. Just to highlight a few equipment alternatives or suggestions that we might have. Temporary stairs designed to provide safe entry in an open cut excavation with handrails and non-slip stairs. Stairs into shoring systems can also be facilitated. And also vertical ladder systems clamped onto the trench box with options to add catwalks to bridge gaps up to 10 feet. So we'll get into the products here available in the trench supplier world. An aluminum trench shield used in shallower excavations or when machines are being restricted by weight capacities. These boxes can be pre-assembled and lowered into the excavation or assembled and installed as you excavate. Common product used when hydrovacing, as you can add panels as it's being lowered. Steel trench shield. Steel trench shields come in many different variations and configurations to meet your application. Depth, pipe diameter, weight restrictions, and site conditions will have a factor when it comes to determining the right trench box for your application. Pipe clearance is up to 10 feet for box culvert or large diameter pipe installation, and gated panels to shore the end walls around existing pipe are all available. Slide rail systems. Slide rail systems have become a key product in the marketplace that provide protection for the worker along with reducing the footprint of excavations. With more utilities being installed through trenchless methods, slide rail has seen its benefits in bore and receiving pits, along with deep excavations for lift stations, manholes, and pipeline integrity digs. With a review from our engineers, these systems can be utilized in excavations with a surcharge load for rail and road traffic, building foundations, or hydrostatic pressures from a high water table through a site-specific plan. Safety and rescue retrieval systems. We have a number of different accessories to enhance the safety on your job site. Clamp-on guardrails systems, walkway access platforms, vertical ladders, dab and arm systems, and temporary stairs are all available to ensure your workers have a competent or compliant safe work site and a means of entering, exiting the excavation. Hydraulic and air shoring systems. Used for mainly shallower utility excavations, hydraulic and air shoring is a low-cost solution for electrical duct bank work, water and sewer repair, or shoring in between crossing utilities. Pressured with environmentally friendly hydraulic oil, CO2 gas, or compressed air, you can manually set the bracing where needed and apply active pressure upon the earth to prevent a cave-in.
Awesome. All right. Thank you. Thanks, Jarrett, for the presentation, the information here. If there are any questions, please put them in here. I got a couple here. We'll start with. Just kind of guessing, in your experience going through in your line of work, what have you typically seen, like in terms of some of the depths and the widths? Like what are the typical kind of constraints when it comes to like a typical shoring system or what's your typical kind of limitations in terms of depths and widths? Let's kind of talk some trench width.
Yeah, a lot of that starts with just what's in the ground, what's known and what's not known. A lot of underground infrastructure work The cities are getting older, new pipes are being added. A lot of new utilities are going to a deeper depth because of the existing utilities that are currently in the ground. So, open cut used to be the method, but now that you have, fiber optic line, gas line, water sewer lines, any of those type of utilities, just prevents you the ability to open cut, and then a trench box is almost used in every excavation now, whether it be trying to reduce the footprint of your excavation, or like I said, you just can't open anything up. So dimensions change, depths are constantly changing, soil conditions have a factor to it, because one day it's been dry solid clay, you had a rain overnight, and now that changes the excavation. So you might need to change the size of your trench box because of the deteriorating soil conditions. So there's a lot of different factors. There's no real silver bullet answer to what trench box works best. It all depends on, as soon as you put a hoe to the ground, what does your excavation look like? And things constantly are changing. So whether it be width, depth, unknown utilities, we all have that all comes into play when we're trying to design or come up with the right shoring system.
And I guess maybe totally understand. There's a lot of factors that come into play here, but what would be like a typical, what are the kind of the typical depths that the trench boxes are going down to, and typical widths? Like, what is that in general?
A lot of the utilities start, call it in Edmonton, 10 to 12 feet in depth. Width, a standard trench is probably 4 to 5 feet wide. But if you have multiple utilities in a pipeline job, we've had widths up to 20 feet, 24 feet wide to accommodate multiple pipes in that one trench. So whether it be, civil work, 4 to 5 feet is your average width. Oil field, typically start at 10 to 12 feet wide, or wider if necessary. And depths can be, with a slide rail system, typically 32 feet deep without any sloping as a straight wall shoring system. So we have had jobs at that depth or even deeper, 40, 45 feet. So we would have a sloping plan and a shoring plan to get down to that depth. So like I said, a lot of the new infrastructure are going to those 10 plus meter depths for installing new utilities.
You kind of spoke about groundwater prior. What's your thoughts or experience in terms of trench boxes, and how do you deal with the groundwater issues? Because we're not really sealing anything off. Is it just dewatering, or is there anything else you kind of look at?
Yeah, we typically advise the client to have some type of dewatering plan. Along with the engineers that look at our site-specific plans, they're always putting a condition in there to dewater to the base of the excavation. So whether that be, well pointing on the outside of the system, having sumps installed, you want to try and draw that water away from the system as much as possible. It doesn't always happen. Sometimes it's coming in so fast that you can't deal with it. A lot of pumps. Sometimes we might even just take a time out and say, we can't advance this system. The water is way out of control, and we need to figure out a way to deal with this first before we continuing advancing the system, because we don't want to put additional surcharge pressures if the system isn't capable of it, and create a risk for workers, the system, and such. So we need to have conversations around dewatering. How do we deal with this water? Have those conversations, and once we do determine how we're going to control it, put that plan in place, and then hopefully continue on with our excavation system and project.
Excellent, thank you. I got another question here. I've seen incident examples of cave-ins at the end walls. in your experience, what are some of the root causes and the things to look out for in this example?
So when you're working in an excavation, if your end wall isn't protected by a solid trench wall, a shoring system, that vertical wall needs to be sloped out. So when we're talking about configurations of shoring, we always ask, are you looking for two-sided application, three-sided, or four-sided? We're talking about how many walls of protection are you required, because if you can't slope out any of the ends or the sides of that shoring box, you should be looking at a four-sided application. You don't want to pose a risk of a worker working inside the trench box, but up against a vertical wall, because if that caves in, you're going to have a hazard inside there and potential injury or worse. So you want to find a way to shore off that end wall with an engineered system. You know, there's ways you can do it with an engineered plywood, road plate, an actual pinned on panel, so that worker is safe working in that zone up against that vertical wall.
Awesome. Thank you. Got another question for you. In your experience, when it comes to maybe, let's say, the design or specification or even the installation of, I mean, I think there's a lot of different aspects here, but let's just talk about from an installation perspective. What are, in your experience, what's overlooked, or what are some of the, maybe we'll call it lessons learned, maybe a better way of describing that. But you know, from an installation perspective, maybe let's talk about that, and then maybe even talk from a design perspective. And you know, what I'm also looking for here is just kind of these kind of the key takeaways maybe that the audience, you know, when you're considering in terms of this, you know, installation or design of these kind of things, so that the audience here can get an, you know, just maybe have those takeaways to have in the back of their minds as they're contemplating or, you know, looking at excavations. So maybe let's just start here at kind of like, what are some of these things that are missed, overlooked, or best practices kind of thing related to installation of shoring?
I think the biggest one is to really understand what your soil condition and classifications are going to be, so that when you're relaying that information to a shoring supplier, if you're going 12 feet, that you're at a true 12 feet in depth, and you understand your soil classification. So if I'm talking C60 C-type soil, and a trench box is rated for 12 feet, that you don't take that trench box deeper than the tabulated data chart. I think a lot of people, you know, plan for it to be 12 feet, spec out a trench box for 12 feet, but at the end of the day, it's like 16 feet deep, and they're like, oh, you know, let's just use this box anyway. And in that situation, that box might be maxed out at 12 feet. So, you know, you're putting risk to your workers, because you're putting a trench box in a position where it might not be capable of handling the loads of the soil at that depth. Now, given there is a safety factor to the shoring systems as far as an engineering take on it, but you know, we don't want to push the limits on that. We always want to provide the right trench box for your application. Like I said, whether it's 2, 3, or 4-sided, depending on how many ends you can slope out safely, according to the OH&S regulation. But for me, it's just talking to your supplier and ensuring that you're relaying the right information for us to provide a safe system is kind of where I would start off with.
Is there any and I actually don't know the answer to this, so I'm just a question for myself. Is there any obligation or requirement, let's say, for a shoring supplier to verify on-site conditions, or is that up to the user kind of thing?
It's an end user piece of it, because we only know what we know through conversation. You know, we're not geotechnical engineers or anything like that, so we can't you know, specifically say what type of soil you're in, and things may change as the site progresses. So we always lean to the end user inspecting the trench, making sure the trench box is assembled correctly. We as a rental supplier need to provide a rental ready system that doesn't have any deficiencies or defects to it, so that when the end user installs it, that it's safe and compliant based off of the information that they see. If they don't know that information, we can utilize our engineers to analyze the soil, analyze the loading from traffic or railways, and then they'll take on some liability as far as making sure that the system that we provide is accounting for all factors based on the information that we were given. If anything changes, we're to advise the engineering company of what's changed so they can review and advise whether we progress or not, or if we need to, change the system or tweak it for whatever reason. But a lot of it is on the onus of the end user to make sure it's built properly, it's in good working order, and that it's designed for the excavation limitations of that trench box.
Excellent. Got another question here. What's the maximum depth for using air shoring?
As far as tab data, so the tabulated data is a blanket statement. They've labeled it at 12 feet. Now there's ways to extend that deeper, but that would be required by a site-specific engineered plan.
Okay. Another question here. Is there a certain ticket or training certification needed for the workers, I guess, working inside trench boxes, or the installation of them potentially?
That's a good question. I haven't seen anything in the regulation as far as a specific training required in the industry. I know oil and gas likes to see ground disturbance courses. I think there's a level 1 and a level 2. A lot of it comes to in-house training competency through the employer. We can provide guidance on, trench safety 101, kind of the stuff that we're talking about today. We really focus on assembly training through the manufacturer's assembly and disassembly procedures. So a lot of companies have been asking for that in the pre-kickoff season, is to, they have basically a whole new crew of new people, and just going through understanding tabulated data, what it means, how to safely put trench boxes and shoring systems together, the pins, making sure the pins are in the right place. So as far as a training required, I don't believe there is. I think every company is different. Every industry is different. There are courses to, like I mentioned earlier, that can help broaden your knowledge of underground safety. And there's also, I've seen in the oil and gas industry as well, they've built their own ground disturbance courses for their employees to take.
Excellent. Got another question here. Have you ever faced boiling water from the bottom of a trench due to high groundwater? What would be the best solution to control it?
Those jobs are very challenging because if you're using your system to try and cut off the flow of it heaving underneath, you're starting to, exert a lot of hydrostatic pressure on the system. So we would take that into account as far as the loading in our site-specific plans, or if it's even just a trench box, you're getting a lot of heavy deflection in the panel. We would talk to the manufacturer, see if that deflection is still within spec. If not, we might need to, backfill and abandon that excavation until we figure out what the best plan is. And maybe it's not a trench box or a slide rail system. Maybe you need to do a sheet pile or or some other means of shoring to cut off that flow because of poor soil conditions. So yeah, it's a challenge. It's always warranted a further conversation with your engineer, shoring supplier. I remember doing a job and it was all peat moss, and I think our system sank 15 feet because there was no base stability. It just kind of disappeared, and the more you would dig it out, it would just disappear. So maybe in those situations we just kind of abandoned it, pulled it out, and then kind of went at it at a different direction. So there's, like I said, there's probably no silver bullet answer to that, but it's worth talking to your shoring suppliers or engineers around that.
Okay, this is a question kind of related to the directly to the services that Cooper provides. Does your company provide stamped designs for temporary shoring if needed by clients?
Yes. So all of our systems that we currently offer have a manufacturer's tabulated data sheet, which is a stamped document from the manufacturer that has, as I mentioned earlier, depth ratings, conditions, and parameters around how it's being used. If you have a job or a situation that basically makes that tab data invalid or not the proper document for that trench, we would source out a separate site-specific plan through a third-party engineer who would look at the soils analysis, look at the trench boxes that we're using, and then put their input on whether, what the best product would be. They would stamp that plan specific for that location, and then that would essentially override the manufacturer's tabulated document.
Thank you. Well, I'm not going to ask this question. I think I might know the answer, but let's see. What depth can you go with hydraulic shoring? Does it vary from air shoring?
It does vary. Air shores are pressured at anywhere from 100 psi up to 300 psi. On hydraulic systems, the working pressure that the manufacturer recommends is 750 pounds. So we can get, I think in a C-type soil, we can get up to 20 feet in depth with hydraulic versus air shore, where you would get 12 feet. And that's just based off the tabulated data document.
Oh, very good. Sorry, I thought you were going to say maybe it depends on the soil, but I see there's a difference in the systems for sure.
The soil conditions definitely have a high influence on the trench box depth rating. There's 3 classes: A, B, and C type soils. So in a C60 soil, for example, if your trench box is rated for 10 feet, a B or A type soil, you might be rated for 15 feet or 20 feet. So soil type does have a big impact on the depths of the temporary shoring systems.
All right, I got a couple more here. Would the actual shoring material increase the depths that air struts could be used?
Potentially. I would have to say we would have to look at what material you'd be looking at using. I've heard of road plate being used. There's a different type of plywood. You can use thicker plywood potentially. The manufacturer had a list of materials that was comparable to a 3/4 inch fin form board. But if you have something else in mind, along with using air shores to go at a deeper depth, I would say consult with an engineer, and they may be able to make something work out for you in that situation. Anything's possible with a conversation to have a look at it.
Good. All right, and this looks like the last question here. Curious, what are the typical safety factors used in shoring and trench box planning? And is like 2 times, 3 times?
I believe it's 5 times, but depending on the situation, if we're taking a system to a certain depth, sometimes the safety factor may be reduced to like a 2 or a 3, depending on the soil loading and the manufacturer's engineered system. So I think that varies. I think the goal is a 5 to 1. But I'm not 100% sure on that. I think it varies from manufacturer to manufacturer.
Cool. All right. Well, that concludes the. There's no more questions, so you're off the hook. You made it. So again, just want to say, just want to thank Jarrett for being here today and Cooper Trench Safety. Really informative kind of presentation, and I think the questions were also really good. So again, thanks for being here today, and thanks to everyone who attended. And just again, want to thank everybody here, all the members for supporting CUIIC. And you can kind of see the list here. I think we're up to like 70 members now within CUIIC. The academies, a couple of weeks ago we had the Geotechnical Academy, and it was a well-attended event. Great presenters. So look for more opportunities like that coming out here in the future from CUIIC. And that's it. Thank you very much, everyone. I wish everybody a good rest of the day, and we'll see you at the next CUIIC webinar. Have a good day, everyone.